All right, I've tried to do this multiple times tonight. Karl Popper, he was impressed by the ability of theories that could explain everything, and these are similar. I mean, Marx, Adler, and Freud all had some theories that Popper would have qualified as that. And so one of the ideas behind this is to be human means to feel inferior. Don't worry about the drowning boy scenario, but he liked to find weaknesses in theories that explained everything. Okay, so in terms of Popper, it deals with falsification. And so you have conjectures and refutations. Conjectures are imaginative. It's a type of hypothesis, but you use your imagination to formulate it. There's no mechanical way of coming up with a good hypothesis on the basis of observational data. And so that's why you use a conjecture. It requires, once again, this idea of imagination and creativity. And just like other truly scientific hypotheses, conjectures are testable. In terms of refutations, they're necessary due to the problem of induction, because it's impossible to prove that a hypothesis is true, but you can prove that a conjecture is true. Scientists therefore should spend more time trying to prove that their hypotheses are false rather than true, because that's what science does. It's a little bit more solid, and it is the more rational way to consider truth and falseness. So, with boiling water, for example, if it boils at 100 degrees Celsius, what Popper would say is that you need to boil water at different temperatures and then try to determine if there are other variables that could help water to boil at a temperature that is either hotter or colder than 100 degrees Celsius. So in terms of criticisms, one criticism is simply in theory, and that is that confirmation is provisional and falsification is decisive. And that's this idea that any kind of science that you confirm, a hypothesis that you confirm, that doesn't really make it 100% true. It just makes it true on most occasions. But if you make it false, then that is decisive, and it can mean nothing else. And then in practice, falsification is no more conclusive than verification. And so those are your criticisms. And in terms of a physics experiment, you might try to have one that disproves Newton. And I can give you an example of this in the morning. Rationalism in scientific thinking, the idea behind this is that when there's a conflict between observation and hypothesis, then there are three options for you. You can reject the hypothesis, or you can reject the observation, or you can accept both the hypothesis and the observation and make yet a new hypothesis. So now we have in terms of science and society. So obviously there's a scientific paradigm, just like there's a mathematical paradigm and other paradigms that we will discuss. But once again, just a little refresher, the paradigm is this overarching theory. It's kind of like the idea that all scientists, for example, would wear glasses and they see through this paradigm of glasses. And so there are three basic scientific paradigms: Newtonian mechanics, atomic theory, and evolutionary theory. So in terms of this science and society, we have periods of normal science and then scientific revolutions. Thomas Kuhn said that most scientists were simply solving problems within a certain paradigm, but they were taking the paradigm itself for granted. And so what Kuhn said was that scientists should attempt to solve problems within the framework of another paradigm. And so there are scientific revolutions, and they take place when scientists are able to do just that and look outside the existing paradigm and look at a situation in a new way. So that begins the new paradigm in science, which is the paradigm shift, for instance, from geocentric to heliocentric model of the universe.
Can I read it?
In a minute. So, with science and society, there is no perfect theory in science. I just made up a new word. No perfect theory in science. All kinds of problems and puzzles, they've not been solved yet. And oftentimes when we feel overly confident that problems can be solved by what we already know, we have these periods of normal science where nothing happens. We have no revolutions, we have no shifts, and no progress. And so what happens during these periods of revolution, we see arguments between those who adhere to the old paradigm and those who are in favor of searching a new one.
Can they see that you don't want to do this thing? Okay.
Assessment of Kuhn's position. There were 3 elements. You can read these and take note of them. They're pretty simple. You might want to hit pause to do that. Science and truth. So, is it possible that there's a theory for everything? I think that's what people are on the search of. The ultimate goal of science is to discover that a theory that is so general that we have a complete understanding of nature. And so, in that way, nature is like chess. You may know all of the rules of the game, but not be able to predict the course of any game. And then we can move that into examples of literature and how literature discusses that of nature. And we could think of something like, say, Jurassic Park or even The Lord of the Flies. And it's the whole idea that nature cannot be contained. Scientism is a belief that science is the only way that we can make sense of reality and discover the truth. It's just an elitist view that science is the answer to everything. And that's all I have to say about that.